Students, here we are discussing communication system question number 26 in master question paper. The question is, a super heterodyne AM broadcast receiver has an IF of 455 kilohertz. If it is tuned to a frequency of 700 kilohertz, then the image frequency is, see here image frequency, I am writing FSI, image frequency equals to, there is a formula 2 into intermediate frequency, 2 into intermediate frequency plus signal frequency. Students, 2 into intermediate frequency plus signal frequency. What is intermediate frequency is given here? 455 kilohertz. 2 into 455 kilohertz plus what is the signal frequency? 700 kilohertz. Both are in kilohertz, so I am writing kilohertz. And 455 into 2, that is 2 5 are 10, 2 5 are 10 plus 1 11, 2 4 are 8 plus 1 9 10 plus 700, 9 10 plus 700 kilohertz, and that equals to 910 plus 700 means how much? 1610 kilohertz. This is the answer. So, option 1 is the correct answer. 1610 kilohertz is image frequency. Students, one more question is asked in communication system. That question is related to noise topic in communication system. What is the question? And master question paper, question number is 27. The question is, when the temperature of a resistor is doubled, then the RMS value of the noise voltage across it is. This is the question. So, noise voltage due to resistor formula is under root of 4 kTBR, K Boltzmann constant, T temperature, B bandwidth, R resistor, under root of 4 kTBR. So, from the relation, what is the relation between temperature and noise voltage? Noise voltage is directly proportional to under root of temperature. Noise voltage is directly proportional to under root of temperature. Then noise voltage Vn1 by Vn2 equals to under root of T1 by T2, under root of T1 by T2. Here noise voltage is how much? I am writing V only, Vn only. Now is asking second noise voltage Vn2, and one condition is mentioned, if the initial temperature is T and now the temperature is doubled to T. So, T will be cancelled, then Vn2 equals to, I am writing root 2 into Vn. What is the root value? Root 2 value 1.414. So, when the noise temperature is doubled, then noise voltage increased 1.414 times of its previous value. So, correct answer is option 4. Student, this question is related to analog electronics. In analog electronics, this question is related to op-amp, operational amplifier. In master question paper, the question number is 22. The question is, the circuit shown in the figure below can be used as? Yes, the correct answer is logarithmic amplifier. In classroom also we discussed, generally operational amplifier, input resistor or feedback element is also resistor. So many applications, that is linear applications of op-amp we discussed. But here one standard bit I am explaining, this is feedback element position. If the feedback element position is a diode, if the feedback element position is a diode, then the circuit diagram acts as what? Log amplifier. What is the answer? Log amplifier if the feedback element is diode. Similarly, in place of resistor, if here diode is there, then it is anti-log amplifier, that are standard bits. and we know that when diode in forward bias, when diode conducts forward current equation, I equals to I naught into e power V by eta Vt, V by eta Vt, I equal to I naught into e power V by eta Vt. So here when voltage increases, the current will be exponentially increases, the current will be exponentially increases. The same equation from this relation I am writing in terms of voltage. See here, I by I naught equals to e power V by eta Vt. Then from this equation, V by eta Vt equals to what? Natural logarithm of I by I naught. I by I naught. From here I am writing V equal to eta into Vt, eta into Vt, natural logarithm of I by I naught. So now I want to write current in terms of voltage. Then the voltage output voltage is directly proportional to natural logarithm of this voltage current I. Hence it is a logarithmic amplifier, students. That is from derivation. But you remember, as a standard bit, if the feedback element is a diode, that is log amplifier. If the input element is a diode, then it is anti-log amplifier. So correct answer is here logarithmic amplifier. Option 3 is the correct answer. Students, now we are discussing digital electronics question. Only one question is asked in electrical question paper. Serial number is 23 and the question is related to sequential circuits. In sequential circuit, the question is related to flip-flops. In JK flip-flop, if the input of K is inverted from the input that of J, then the resulting flip-flop. Yes. We know that there are 4 types of flip-flops. One is SR flip-flop, another is JK flip-flop, D flip-flop, T flip-flop. He mentioned 4 flip-flops. And out of these 4 flip-flop, a universal flip-flop is JK flip-flop. Universal flip-flop is what? JK flip-flop. From JK flip-flop, we can convert all flip-flops, SR flip-flop, D flip-flop, T flip-flop. So here I am explaining 2 standard bits. This is JK flip-flop. A JK flip-flop consists 2 input terminals, J as well as K. A flip-flop is controlled by clock signal, and flip-flop consists 2 output terminals, Q and Q bar. Q and Q bar. See here very important 2 bits I am explaining. A D flip-flop is obtained from JK flip-flop. A D flip-flop is obtained from JK flip-flop by connecting a NOT gate, between JK input terminals. By connecting a NOT gate between JK input terminals, then what type of flip-flop? D flip-flop. The question is same thing. If the input of K is inverted from the input of that of J, then the flip-flop is, answer is D flip-flop. What is the answer? D flip-flop is the answer. Suppose same JK flip-flop, here I am considering, this is J, this is K, and here this is clock. The 2 outputs are Q and Q bar. Now if JK input terminals are connected together, then the flip-flop is what? T flip-flop, students. JK flip-flop is a universal flip-flop, and here a JK flip-flop, from JK flip-flop we can obtain SR flip-flop, D flip-flop, T flip-flop. Here is combining because JK input terminals between there is a NOT gate, means we assume there is only one input. In SR flip-flop there are 2 inputs, S and R, but according to question, here question may be related to D flip-flop or T flip-flop, because in JK input terminals is connecting one NOT gate only. So if J is 0, then K is 1, if J is 1, then K is 0, then if a NOT gate is connected between JK input terminals, then it is D flip-flop. Students, this question is related to microprocessor, and there is also only one question. Serial number is 24. and the question is related to 8086 microprocessor. What is the maximum length of machine language instruction for 8086 microprocessor? So, 8086 microprocessor is connecting with different interfacing devices, peripheral devices, and they are working with 8086 different instructions. So, to load different instructions in machine language, is asking what is the maximum length of machine language instruction. So, here to load one instruction, the minimum length is what here is mentioned 1 byte and maximum length is 6 bytes, that is predefined standard bit. So, here is asking the maximum length of the machine language instruction in 8086 microprocessor is how much? 6 bytes is the answer.